All right. Hello, everybody, and welcome back to another episode of Polkadot Deep Dive series. Today, we will be covering some notable changes that happened on the V1 Polkadot release on the context of the Polkadot release analysis. Um, Today, along with me, we have a Juice, my colleague from Delivery Services, and PG from the Smart Contracts team as our guest. The agenda for today will be like introducing the Polkadot release analysis. We'll be talking about what it is, and then we will going into like a few of the changes that happen in this release v 1.0. Then we will dive into like the specifics of the multi-block migrations applied to the palette contracts with PG, and we will end up talking a little bit about the fellowship, LTS, and what is about to come with the future releases, right? So let's jump directly into what is the Polkadot release analysis, right? Um, we can say that it's like an aggregation of changes that have happened in the release that we're covering, right? In the specific analysis that is affecting the builders in the community, in the Polkadot community. These builders don't necessarily have to be like parachain builders, right? They can be wallet developers, they could be dApp developers, integrations like just node operators, just players on the ecosystem, right? As well, like Polkadot release analysis tries to help with the heavy lifting that is like following the breaking changes that are happening, right, in the code bases, and of course, like a resource for the community to have all these like more impactful changes like gather somewhere so they can like go later in time and review them, or like maybe it could be a resource for them to help with upgrading their chains, for example, whenever they need to apply these changes. Of course, like we are aware that the teams out there like track the changes that impact them, but still we think this is a very good resource, and the community, the feedback that we have got from the community has always been like pretty positive. Of course, these reports are opinionated kind of in the way that, well, at least the PRs that we're including in them are selected by people, by me, by my colleagues, and so we try to pick the ones with the most impactful ones, right? um we will talk a little bit more about like the process of how we create this later on during this deep dive session. But right now, let's talk about, okay, what is not the Polkadot release analysis, right? So it definitely it's not a substitute for the release notes. Please read the release notes. They contain like pretty valuable information. Um, so don't skip that part. Um, the release analysis is definitely not a guide on how to upgrade between versions. Uh, it has never tried to be. It of course like uh, contains like really interesting information for doing that, but it is not a guide. We have never tried to abort the process in that way. We have never received such feedback, so it needs to be a guide, right? Um, and of course, like, well, every runtime, for example, out there is different, right? Like we couldn't. It would be like very difficult to put out there like a generic guide that is a blanket guide for everybody that applies to everybody in the same way on how to do these upgrades, on how like these like breaking changes might be impactful for you or not, or like, so it's like there are like more general guidelines on how to implement like migrations or how to like do implement changes on your platforms, but of course like they have to be like taken with a case by case scenario in terms of like level of detail of what to look at, what to pay attention for, and so forth, right? So with this in mind, let's jump into like um, the release itself. It's something that you can find published on the Polkadot forum under the tag release analysis. We have been like publishing it for a while already, like a couple of releases. um, community seems to like appreciate the effort, so we continue improving our process, and we continue like publishing it like very happily. We are super happy about it. And so let's tap into how do we create like this analysis, right? um, we kind of like follow like these three kind of phases approach, like um, to say something, we start like pulling all the merge changes that have happened into like different repositories that are like Substrate, Polkadot, Cumulus mainly. Right now, with the changes that have happened around 1.0, right, Fellowship and the monorepo in parity, well, we are adapting to that, but those are our main code bases to pull changes from, both like node and runtime side. And then like we assess the impact that these changes have on builders, right, on players, on different like personas on the ecosystem. So with that assessment done, we start composing the whole report, and we divide like the the changes in three categories, which is a high, medium, and low uh, impact. Before jumping into like what the report looks like and what each category might contain or not, I also would love to do a shout out to like Polkadot and the author of it, which is like Secret Martin. This whole like Polkadot release analysis report is like pretty influenced by it. For those who don't know this, it's like a list of every change that has happened into the release, right? You can find it like in that link that is on screen. It's pretty cool. So if you have read the release analysis already, you might be aware of this, but for those who have not, this is more or less the four parts that a report will contain, right? You will have an intro with a summary, a little paragraph talking about it, introducing you to what you're going to find. It will point to the runtimes that are part of that release, and then tooling, like versions of tooling that works with the release that we are covering, right? And then we have like high impact changes. These might be, I don't know, big deprecations, huge migrations, like very impactful new features that are out there, like major breaking changes that will translate into a lot of work for teams, for users of these code bases, right? Medium impacts here will have maybe lighter changes in terms of what users will have to do, maybe some breaking changes that don't need like a heavy workaround or a heavy amount of time to be fixed, right? Maybe and for the low impact section is mostly informative. Maybe new palettes that are out, maybe something related to the tracks of governance, something on those terms, like light impacts, right? Um, this is more or less the skeleton of what our report will look like at the moment. Um, but we are always looking for feedback. And I would like here to stop for a second to point to a form that is linked on every report right before the summary. We are pretty much well looking for any opinion out there in the community about these reports. Anything that you might want to see that is not there, and anything that can be improved or changed. We are open for feedback, right? Of course, we are always adapting and trying to improve the process, right? To be able to publish a really nice content out there that is helpful. For example, right now, aside on working on adapting to the monorepo and the fellowship, right, we are trying to get this whole like how we work like into an open repo, so we can be open to contributions from the community, such that, for example, right now the tooling section only covers like tooling that is developed by Parity, because we don't have the capacity to be pulling like changes or like track changes from all the tooling out there. This way we are hoping for the Polkadot release analysis to contain more information from the community as well, not only from these code bases, but that will come with time. We're working on it. And then with this, I will pass it to my colleague, Ayush, who will cover like some changes that are happening in the release 1.0.
Ayush, you are muted.
I'm sorry, I was muted. Yeah, so let me start again. As you know, Polkadot recently released 1.0.0 version, and this release features notable changes like a complete shift in gas metering for pallet contracts, a starting point for a multi-block migration framework, pallet aura following multiple blocks per slot, and many more. So there are many other changes introduced as a part of this release, but I'll be covering only important ones in this session. The first one, like as a part of this release, a new palette, asset conversion palette has been introduced. This palette is based on Uniswap V2 logic. We can also say it as a simple automated market maker palette. This palette allows you to create a liquidity pool for two assets, provides the liquidity and receive back an LP token, exchange the LP token back to asset. It swap a specific amount of asset and also swap some asset for a specific amount. So this palette like also allows to query for exchange price via runtime call endpoint, and also allow to query the size of the liquidity pool via runtime API endpoint. If you want to learn know more about this palette, please check the README or forum report. The next one is adding ability to add and remove enumerable collaterals. Before describing this PR, let me explain why we needed this change. So, with the release of XMV3, some big technical changes are planned for system parachains. As this functionality moves into system parachain, collaterals on the chain play an important role for the network and should get rewarded for their services. However, collateral selection method have not changed since the launch of StateFine. So this pull request, this change is one of the steps to refactor collateral selection method. As a part of this pull request, two new dispatchable function, add enumerable and remove enumerable have been introduced, which will allow you to add and remove individual collateral from the enumerable cell. The next important change is renaming statement to SFF. So statement is a system parachain on the Polkadot, also referred as common good parachain, which allows the deployment and the transfer of asset, both kind of asset, like fungible and the non-fungible tokens. And it serves as the fundamental infrastructure that enables the Polkadot ecosystem to communicate with the rest of the on-chain and off-chain environment. The name statement has introduced a lot of confusion across the ecosystem, especially with its counterpart StateMine. So to reduce this confusion, it was supposed that system change should just be named after their technical functionality. So as a part of this change, the statement has been renamed to SFF. However, even though the name has been changed, this does not make any impact on the Polkadot builders. There are no changes on the chain spec or the endpoints, even though the name has officially changed. Coming to the next important change, which is related to Aura Palette. As we know, like Palette Aura has a key role in the block authoring process. Aura works by having a list of authorities who are allowed to produce block, and these authorities must be chosen before block production begins. And all authorities must know the entire authority set. So usually time is divided up into the slots of a fixed length, and during each slot, one block is produced, and the authorities take turns producing block in order forever. At the moment, only one block is produced in each slot. This change optionally allows sequential blocks to be authored within the same slot. My question is how? So a new config type allow multiple block per slot, has been added in palette Aura. So if you are using Aura consensus for block authorization, this would be a breaking change and fail the compilation. So we can set its value as false to maintain the current behavior, or like if you are looking for enabling the asynchronous backing, we can set its value as true. But this may require some other changes alongside. But like for more details, you can please check our forum report or PR description. Now the next one is related to contract palette. Before release 1.0.0, fuel consumption was being measured via gas host function invocation. For this, the executed WASM block needed to be instrumented first. That means like the host function calls needed to be injected into each metering block of the code. Now we use built-in WASM fuel metering instead, which allows us to get rid of instrumentation, and it saves both storage, because we don't need to store the instrumented code as we like don't need to store the instrumented code alongside original code. So it saves from storage, and it also saves performance, as like calling host function in every block is costly operation. So it also saves the performance. So this change like also translates into cost saving for both contract author and users. But to accommodate for these changes, all the users of the palette contract need to run a migration, which is provided in this pull request, which removes code storage with all instrumented contract codes. It renames owner info into code info, which incurs moving to the storage map. As the migration frees up a decent amount of storage, deposits attached to it are refunded. So this is all about this PR. Now coming to the next one, which is also related to contract palette. This is about multi-block migration. So if we are using contract palette, and if we are doing the runtime upgrade, like if you are upgrading to the new version, we need to perform a large storage migration, and all migrations need to happen in a single block. As a part of this pull request, this change, this problem is solved by introducing multi-block migration in the contract palette. But at the moment, this feature is available only for the contract palette and will be generalized to the rest of the frame in the future. Now, I would like to invite Peer, who is the author of this multi-block migration feature, who's the author of this PR, and he will describe in detail.
Thanks, Ayush, and thank you guys for having me on this deep dive. So I will talk more about this contracts multi-block migration PR. And as Ayush mentioned, so palette contract, for those of you who are not aware, is like the palette in charge of executing your WebAssembly smart contract. So if you develop your smart contract with Ink or with Solidity and compile them down to WebAssembly with Solang, like this WebAssembly will then be executed on-chain by palette contracts. So as you can imagine, the palette maintains quite a lot of state, as Ayush mentioned. We have all the the code, the WebAssembly code on chain, the metadata associated to the code, and your contract instances and all of their states. So because of that, our migration with palette contracts can be quite heavy. And as you mentioned just before, with like this gas metering PR, we had to basically touch all of this code storage, and depending on the configuration of your chain, a contract can be in the hundred of kilobytes. And so if you have a very popular chain and you are trying to update all of these storages at once, you could basically exceed like the maximum amount of weight that is allowed in a block and break your chain. So for all of these reasons, this was kind of a top priority for us to come up with a better solution, and that's that's for the why we did this PR, and now I guess I will dive in a bit more into the code and show you what we have developed here. So I'll switch to, if I can, yeah, my IDE. So the first thing that this PR is introducing is this new storage, migration in progress. So unlike traditional migrations, where you basically do all of your logic at once inside the on-runtime upgrade function, we don't do that with this new paradigm. Instead, we simply set this value storage, migration in progress, and that's basically all we do inside this migration. The actual migration will take place a bit later. And so what this storage hold is a cursor, which basically defines where you left. I mean, we break down your migration into multiple steps, and I will talk a bit about that later, into migration step. And each step can encode like the last storage that has been updated, and that's what's this migration progress storage hold. And so when this storage value is set, it basically means that there is a migration in multi-block migration in progress. And so the first thing we want to do is to make sure that you don't interact with your palette, right? Because we haven't migrated yet. We just have set this flag to true, basically, if you want. And so if I jump to our extrinsics, you will see that they all now start with this ensure migrated statement. So that's true for upload code, where we upload your WebAssembly code, but for all of the other ones as well. And so what this line of code is doing is basically checking if the storage has a value, and if it has a value, your extrinsic will return a dispatch error saying that there is a migration in progress. Now, when do we do the actual work of the migration? We do that through two entry points. The first one is on idle. So on idle, with like the remaining weight, we will basically run the migration code in a loop here until we exhaust all the weights. So that's what we are doing here, and then we will continue with whatever we need to do in this hook. The other endpoint is a new dispatchable that we've called migrate. So that's basically like the only dispatchable that is whitelisted. And so this dispatchable takes a weight limit, how much weight you want to invest into the migration. And it will use like that weight, up to that weight, to run as much migration code as possible. So here we run the migration. And one thing to note here is that because it's helpful to the chain, we actually waive the fees if you are doing some actual work. So you can see here that the pay fees are equal to no. So you're not charged for calling this extrinsic when it's doing work for the chain. So that's how we initiate the multi-block migration. Now, the migration itself, as I said before, we have introduced this new trait, migration step here. And all of our migrations basically are broken down into migration steps and stored into like this migration folder. Each of them define a struct that implement this migration step. A migration step has basically three main, properties. The first is like the version is migrating to. The second one is like the max step weight that a step can take. So we need that because the migration framework needs to know whether or not it can, execute one more step, or if it should stop and read him later, maybe at the next block. And finally, like the main function, the step function, is where you execute the migration logic. So usually in this function, you will just migrate a single key. And you can see here that it's taking mute self as a parameter. So basically what's happening is that we get from the migration in progress like the state of the last migration step. Basically, we decode it and we pass it, and then with this decoded migration step, we execute, and then we're going to keep executing until either we run out of weights or the migration is fully completed. So maybe it's even clearer if I show you one of this migration. So here we have migration v9, and you can see that it holds like one property, which is like the last. In this migration is like basically updating the code storage, which is a storage map. And this migration step holds the last hash, like the last key that was updated. And so if we look at the migration step implementation, so we see that the version is 9 as expected. The max step weight, so we have benchmarked that with the benchmark CLI, and we have like this V9 migration step that tells us, how much weight the worst case scenario basically is taking. And then we have like this step function here, which is pretty short. So it's nice to use that as an example. But basically all of our migration follow like the same pattern. So we start by taking the last key from self that was migrated, and we build an iterator from that, right? So if we didn't have any keys, we start from basically the beginning. Otherwise, we initialize an iterator from that key. And then we call iteration next to get the next element, basically like the next element in our storage map. And in that case, we basically take the old struct that was in storage and add like this new field. That's the only thing that this migration basically is doing here. We insert it back into the storage, and importantly, we update this, since we have mute self, we update the value with like the last code hash, so that next iteration can start from this code hash. And then finally, we either return whether or not the migration is completed and how much weight it took. And so because the migration framework is going to run that in a loop until we exhaust all of the weight that we have, and because it maintains like the value of the last step in state in storage, we can span these migrations across multiple blocks if needed. So yeah, this is kind of like the meat of this migration framework. Then once we have a migration step, we can basically we pass that to the runtime configuration as like a tuple, so a sequence of migrations, and that's basically all we need to do. A few things to I think that's all I wanted to cover. A few things to point out is that that I like about this framework is because we use like this cone pattern in Substrate of passing a configuration tuple, and because like this version are stored in a const value, we can do some static checks. Let me show you the code for that. So here we have the migration sequence that is implemented by tuple, and you can see here that because we have a tuple, we can, at compilation time, make sure that the configuration that you've passed to the runtime, all these migration steps that you've passed to runtime, that we can ensure that they are passed in order and that we don't have gap, right? So if you pass V8 and V10, it will just not compile. So that's pretty nice. Another thing to point out is that we have also implemented all the try-runtime hooks. So we can have a few more integrity checks when you dry run your migration with try runtime. for example, one thing that we do is that we can verify that you have passed all the steps that are required to go up to the pilot version. And if you have added a step that has already been passed in a previous migration, we will also throw an error thing that you don't need to include that. You can just remove it and switch a few bytes from the final runtime. That's pretty much what I wanted to cover. Before as a conclusion, I also wanted to point out that the core frame team is working on a similar PR, a more generic solution for frame and all the palettes that will fix some of the shortcomings that we have in our implementation. I think this upcoming framework will integrate a bit more nicely with the executive and block builder. And instead of like failing the endpoints, the external while the migration is in progress, it will just like hold on, keep them in the transaction pool, and only start taking them from the transaction pool when the migration is fully done. So that's coming up as well. That's everything I wanted to cover. You can take over for the rest of the presentation.
Thank you very much, PG. That was really nice. Yeah, so just as a final mention, before finishing this deep dive, I wanted to like touch base on, okay, like 1.0 has been like a very crucial point, a very crucial release, right? Like it has not only been a release, it has been like a point in time where different things have happened. Like the runtime code base have been like moved to the fellowship. Now it's like living under the fellowship, which means that it's also like a step forward into like decentralization, because like the code is now owned by the community, by like Polkadot community, right? So from here as well, like inviting every contributor out there to like submit code changes to the Polkadot runtime on Polkadot Fellows organization /runtimes. You will find it there. Open RFCs or like join the fellowship. As well, I wanted to mention like the long-term support, the LTS releases, which will have like a 6 months support from now on after every release happens. That should like ease like the life of like many teams out there, like trying to use like these releases for a longer term of times, because like they will get like all the security patches, right? And with this, I will just say once again that we are like looking for your feedback on the Polkadot release analysis. We are still hoping to make it useful for all of you out there. And well, this has been like pretty much the session for today. You can see like our names there on the right, or like other like useful links or sources where you can go and find like more information around this. So thank you very much, and I think we can address now any question if in case there's like any. I don't see any question myself, but all right. So if there are no questions, we can call it here today. Thank you everybody for joining, and see you in the next one.